This is Nagendra from 8th CSC MSRT. In this video, I will be describing about one of the most popular open source software, that is Cryptool. Cryptool is a freeware program which enables you to apply and analyze cryptographic functions. It has the typical look and feel of the modern Windows applications. Cryptool has implemented almost all the state-of-the-art crypto functions and allows to learn about use of cryptography within the same environment. The method available include both classical and modern crypto systems. It implements more than 300 algorithms where the users can adjust these within own parameters. The graphical interface, online documentation, analytical tools, and algorithm of Cryptool introduce users to the field of cryptography. Basically, a free software program for creations, awareness of security issues, for learning and obtaining experience of cryptography, also for demonstrating encryption algorithm and analysis procedure. Yeah, let's now start with download and installation of Cryptool 2.0. Go to Google Chrome, search for Cryptool 2.0 free download. Yeah, click on link Cryptool 2.0 download. Scroll down. Here you get the download link of Cryptool 2.0. The download is started automatically. Here you see the file downloading. The software is 58.4 MB in size. Yes, now the download of Cryptool 2.0 is completed. Click on Cryptool 2.0.exe file. It shows a small window. Here you select the language English. Click on OK. Yes. Yeah, setup window is opened. Click on next. Click on agree. Next. Click on install. The software is being installing. Now launch the Cryptool 2.0. Here we can see Cryptool 2.0. In this tool we can do cryptography for encryption and decryption. We can do cryptanalysis, hash functions and mathematical functions. Also we can create our own QR codes, protocols, steganography, etc. Now let us know what is cryptography. A cryptography is a method of transforming a plain text or a meaningful message into encrypted form and retransforming that encrypted message back to its original form. It has few components like plain text, cipher text, cipher and a key. Yeah, plain text is a original message or a message which is generated by the sender, and cipher text is a system generated message or encrypted message which is received by the receiver. And cipher is an algorithm written or executed for transforming a meaningful message into meaningless message either by the methods of transposition or a substitution. And finally a key, it is like a secret code which is known only by the sender and the receiver. In this cryptography we have two methods, namely classical methods and modern methods. And next is cryptanalysis. Cryptanalysis is used to break the security which is given by the cryptography and gain access to the encrypted message without knowing the actual key value. For example, if you have any encrypted message, it is analyzed by the cryptanalysis and can be converted to actual plain text without knowing the key value. And the next is hash function. It is an function that can be used to map data arbitrary size to the data which is fixed size, and the values which is returned by the hash function is called as a hash values. And last one is the steganography. It is the practice of protecting a file, message or a video within the another file or a message or a video. Now I am going to demonstrate a few examples of basic cipher encryption. I will select in classical method, Caesar cipher. Caesar cipher is also known as shift cipher or a substitution cipher, where each letter in the original message is replaced by corresponding to the certain number of letters up and down in the alphabet. Here you can see a character mapping, that means with respect to key as integer. For example, here the key as integer is 10. That means A is mapped with K. K is 10th letter of A. For example, if we take key as integer as 2, A is mapped with C, likewise B is mapped with next to C, that is D, likewise C is mapped with E. It follows. Here we can select the action whether to encrypt the message or decrypt the message. Let's encrypt the message now. I will take example as hi, this is Nagendra. So wherever we get the plain text, A will be replaced by C, and wherever we get B will replaced by D. There is no B in the example, so I will go with D. The D is replaced with its second letter, that is F, and likewise the H is replaced with J, and T is replaced with V, and goes on. And now I will run the program. Before that I will I will small the window so we can easily see the input and output, that is plain text and cipher text. Yeah, Now I'll run the program. Yeah, you can see the A is replaced with C. Wherever you get A is replaced with C, and as I said, D is replaced with F, H is replaced with J, and T is replaced with V, and it goes on. As I given the integer as 2, all the letters is replaced with forwarded to its second letter, I mean next to its second letter. Now I will copy the ciphertext or a encrypted message, and I will give an as input to decrypt it. I will paste here the encrypted message, then I will select an action as decryption. I have to give the same key as integer, because what we have given for encryption is to be decrypted using the same key. Now I will decrypt this message using decrypt action. Now I will run the program. Yeah, here I get the actual message, I mean in its original form, that is plain text, using key, same key which is used for encryption, that is 2, and this is a ciphertext which I got encrypted when I given action as encrypt. Now it is decrypted to its original form. So this Caesar cipher can be represented using modular arithmetic. For example, if we take A is equal to 0, B is equal to 1, C is equal to 2, like so on, Y is equal to 24, Z is equal to 25. We can give a, or we can represent it the modular expression like encryption of x, that is plain text, sorry, ciphertext is equal to x plus k mod 26, where x is a plain text, k is a number of shift, that is n number of elements that should be shifted or replaced with respect to the letter, and 26 is a alphabet's letters, that is number of letters in alphabet, number of English letters. For example, if we take plain text as A and number of shift is 2, that is key is 2, so the cipher text will be x plus k, that is plain text plus key. Plain text A is equal to 0 plus key is 2 mod 26. So the answer will be 2 mod 26. So the cipher text will be 2, that is C. So the encrypted message of A is C. Same way, to decrypt we have to replace the plus with to minus in the modular expression. E of x minus k mod 26. This is for decryption. Decryption with respect to modular expression. If we take cipher text as we got output in above example, C, and the key is same as 2, the plain text will be with respect to modular arithmetic x is here the x is cipher text, that is C. So the C value is 2. 2 minus k is a key, that is 2 mod 26. So this is 0 mod 26. So answer will be 0, that is A with respect to the example what I have assigned the value. Here you can see A. So the Caesar cipher is work as like same plain text letters are always replaced with the same ciphertext letters. For example, if we have any repeated letters like in hello HELLO, LL will be replaced with same ciphertext letters. So it has some drawbacks like easy to break. Also we can apply brute force attack because it consists of only 26 letters. Now we will move on to another encryption method, that is playfair cipher. Yeah, here we get the playfair cipher is a manual symmetric encryption cipher invented in 1854 by Charles Wheatstone. The playfair cipher starts with creating a key table. The key table means the 5 cross 5 matrix, which is consists of unique 25 letters in an alphabet, where I and A is combined in one cell, because as there are only 25 spots in 5 cross 5 matrix and there is a 26 letters in the alphabet. So let's see the key value as hello world. Then the first character in the 5 cross 5 matrix goes row wise, that is from left to right. Here is the 5 cross 5 matrix. Here the duplicate letters will be removed. So 5 with the row, here O is removed because already used, and D, here we got with hello word without repeating the letters. Then remaining letters should be filled in remaining space. A, B, C, D already written, E already written, F, G, H is already written, I, I and J should be combined. K, L already written, M, N, O is already written, P, Q, R, R is also already written, S, T, U, V, W is also already written. X, Y, Z. Here we are getting confused because of I and J is combined. Because I will give little space so it comes to same column. Yeah, now you can see 5 cross 5 matrix where I and J is combined with respect to the keyword hello world. Now we need some plain text to encrypt. Here in Playfair cipher, the plain text is splitted into digraph. That means pair of two letters. And if we get any odd number of letters, we can insert extra letter as X. Also, if we get repetition of adjacent letter, we can insert X in between them. Now we'll take some example of plain text. For example, hi, this is Nagendra. So the pair of letters will be hi, that is HI, TH, IS, IS, NA, G, ND, RA. Now for the encryption process, the Playfair cipher uses some rules like whether the letter of each digraph are in relation to each other or not. If both the letters are in same column, then we have to take below letter of each letter, and if the letter is at bottom, then we have to take the first letter of the same column. If both letters are in same row, then we have to take the right of the each letter. If the letter is at end of the row, then we have to take the first letter of the same row. If both letters are not in same row and same column, then we have to take the row letter with respect to the column letter of the pair value. For example, if we take the pair as HI, we have to search here. Here we get the H with respect to I. Here is the I. So H row with respect to I column. Sorry, H row with respect to I column. That is L. So the cipher text will be start with L and again HI. Ith row with respect to H column. So LF. LF is a cipher text for the pair that is HI, that is plain text, which is divided as a pair of letters. Then TH, we have to search TH. T is here with respect to H. So Tth row with respect to H column. So that is N, and then H row with respect to T column. That is W. Then next pair is IS. I and S. So ith row with respect to S column, that is K, then S row with respect to ith column, so that is Q. Here IS is repeated, so K, Q, then NA. N, yeah, here is the N. N with respect to the A. So nth row with respect to 8th column, that is Q. Now
eighth row with respect to n column, that is R. Next G. Here is a G and here is a V. So here G is in same column. So next, below letter of each letter. So G's below letter is P, then E's below letter is D. Next ND, here is N and here is D. Nth row with respect to Dth column, that is P, and Dth row with respect to nth column, that is R. Next pair is RA. Here is R, here is A. So here RA is in the same row. So next letter, write to its next letter of each letter. So R next letter is D and A's next letter is B. Here is our ciphertext. If we take these pairs of ciphertext and convert it back to the plain text using this key, we will get this pair. For example, if we take LF, search in the key table L with respect to F. Here is F. So Lth row with respect to F column, that is H. Then Fth row with respect to Lth column, that is IRJ. So we will get to know that is HI. So we will write it as HI. Like the same way it will go for each pair of ciphertext. So now let's try with the encryption and decryption of Playfair cipher. Here we give the input as hi, this is Nagendra, and in the algorithm we have to give the key value as hello world. Here we can give the key value as hello world. Here it remove the repetition of letter. So let's run the program. Here it's taken as pair of letters. This is Nagendra with removing the spaces. Here is the encrypted form. Let's we compare with the encrypted message. Yeah, here we get LF NW KQ KQ QR PD PR and DP. Yes, we have got the encrypted message. So let us copy this cipher text and let's we decrypt the message using same key table as hello world. Yeah, the key value is also same. So we have to select the option action decrypt and we have to run. Yeah, this decryption is done with this is Nagendra. So this text will be the original message or a plain text. So the Playfair cipher encrypts pair of letters instead of single letters as in the Caesar cipher. Frequency analysis is still possible on the Playfair cipher. However, it would be against 600 possible pair of letters instead of 26 different possible letters. For this reason, the Playfair cipher is much more secure than the older substitution cipher. So that's all with the Playfair cipher. Now let us move on to another method, that is modern method of cryptography with brief introduction. Asymmetric encryption. It is also known as public key encryption, where it is utilizes a pair of keys like a public key and a private key. If you want to encrypt a data with a public key, only the owner of the corresponding private key can decrypt the data. Hence, it is ensured for the confidentiality. Next one is symmetric encryption. It means that the encryption and decryption operation utilizes the same key for the communication parties using symmetric encryption for secure communication. The key represents a shared secret between the both of the parties. So that's all with the Cryptool 2.0. Thank you for watching.